Welcome to the Atoms Precision V2 tutorial series. This tutorial focuses on how to create optical profile files for image capturing devices using the calibration process. The image capturing device could be a camera or an optical scanner. Let's import an image created using an optical scanner. Click the Start tab, select Import Base File, and choose the scanned image file. Atoms Precision V2 allows you to import the most common graphical formats, such as JPEG, TIFF, or BMP. Once selected, you'll be prompted to select an optical profile. In this case, we choose the default profile. Next, click on the Calibration tab to reveal the options for the calibration process. Calibration is required to validate image capturing devices used to capture images of the objects you are going to measure. There are three major tasks that are being performed during calibration. These are image cropping, selection of the contour computation algorithm, and pixel size calculation. The optical profile file is unique for every image capturing device used and has to be newly created for every set of varying settings for that device. It has to be created from new every time the settings change, or can be loaded if the same settings are used again. Now we're going to calibrate an optical scanner. Set all three parameters and save an optical profile file. The first task is to crop the image. Image cropping is used to remove unwanted areas of the imported image, such as clamps and holders. The cropped area is removed from the optical profile file, and it influences the inspection process irrespective of the template loaded. Therefore, we need to make sure that only the unwanted areas are erased. Activate the Image Cropping tool panel with a right-click on the taskbar and select Image Cropping from the list. Now select Enable Image Cropping, choose the Paint tool and mask the unwanted area. To later modify the masked area, use the Erase tool and paint over the unwanted area. The masked area is erased, and the image cropping process is completed by confirming with the Apply button. The second task is to select the contour computation algorithm. Contour computation is the process of distinguishing the real edges of the imported image from the background that defines the boundary of the inspection object. During contour computation, Atoms Precision V2 uses an edge detection algorithm called Sigma Global. This algorithm produces accurate edge detection on images with single color background where there is no variation in contrast. The accuracy of edge detection depends mostly on the image quality. Select Sigma Global from the Mode panel to proceed in this contour computation mode. The third task is to determine the pixel size value. This is determined by comparing the actual size of a geometric primitive object created from the image contour to its dimensions measured by Atoms Precision V2. We only need one measurement value for the pixel size computation to be valid. Go to the Mode field in the Calibration tab where you can find 5 measurement options to select from. These are calibration by distance between two lines, calibration by distance between a line and a point, calibration by distance between 2 points, calibration by diameter, and calibration by specific linear dimension. In this case, we select calibration by diameter. Now select New Circle and mask the contour area with which you want to calibrate. A new circle is created with the diameter shown in the Measured Geometry panel. Enter the actual value of the circle in the Calibration Sample panel to define the new pixel size. Now select Finish Calibration, which will apply the new pixel value to the image. Finally, select Save in the Profile panel to save the optical profile file. Since this is a new optical profile file, we choose Save as New Profile and enter the name and parameter details to save the file. In this tutorial, we learned how to perform calibration for an optical scanner and saved an optical profile file. Thanks for watching this tutorial, and please view the other tutorials in this series to learn more about the features of Atoms Precision V2.